Okay, so we're going to start casing 3D notes. Before we start, I just want to tell you and remind you about the equation of a line, which hopefully we did not forget. It's going to be y equals mx plus b. Again, m means slope, b means the y-intercept. Okay, so the y-intercept is always gonna tell you when x equals 0. So that on the graph tells you that is your starting point. Okay? Your x, don't forget that your x means your input and your y means your output. When you plug in for x, you get a y, right? Okay, another thing that we talk about is that x represents that independent. It's an independent variable because x doesn't need anyone. X is by itself, can act whenever it wants, can change how many times you want. It does not need anything to change. It changes by itself. All right? Y is dependent. The y needs of x. That's why it's the output. Independent is the input, depending is the output. In order for me to get an answer for y, I need my x. Okay? So hopefully you guys don't forget this. We're going to be using it throughout Target 3D. Alright, so let's get started. The main goal for this target is to identify variables and quantities needed to graph the equation. So we're going to get equations and we need to graph them. Alright, so it says, suppose you want to graph the line h equals 15d plus 300. Alright, the main thing I want you to focus is that you need to read each sentence by one. Do not read the problem as a whole. You're gonna get confused. So as right now, just as I read the very first sentence, I know h equals 15d plus 300. We are talking about linear equations again. Okay, based on this, I know y is the h, m is 15, x has to be d, and b is my y-intercept, which is 300. Okay. All right. Since h depends on d, okay, remember I told you y depends on x. There you go. H depends on d. Okay. The vertical axis will be the x-axis and the horizontal axis will be the d-axis. Given the scale on the horizontal axis, so d, right, is a horizontal, that already gave me my values for the graph for the d-axis. Choose an appropriate scale for the vertical axis. All right, what is scale? Scale is like the pattern. What is a pattern? So they're asking you for the scale of h. However, if you notice, h does not have any values. We have inputs, right? We have 10, we have 20, but we do not know the outputs. I don't know what goes there. So all we have to do is use our equation and use our points. Okay, this is like target 3B. We're plugging in points to get an answer. So, for instance, remember I told you x means the input, and I'm gonna get an output, which is x. Whenever I put a number for d, I'm gonna get an output for h. Alright, so h equals 15d plus 300. And again, I'm just using the equation they gave me. Okay, whenever I plug in for something for d, okay, I'm plugging in something for d because I know it. Okay, again, if I put 10, what will be my output? All right, what if I put 10 here? 15 times 10 gives me 150 plus 300. My h has to be 450. That means that when I put 10, I get an output of 450. Oh, And I noticed I skipped my very first point, which I should know it has to be 300. Again, how do I know that? When x equals 0, that tells me that it's going to be my y-intercept, and I know my y-intercept based on b. Remember that? All right, next, you need to figure out the next point. It's the same thing we did with the point of 10. If I put in 20, what am I going to get for h? All right, again, I use the same equation. H equals 15 times 20, because this is D, plus 300. Well, 15 times 20 gives me 300, plus 300 gives me 600. That means when I put in the value for 20, I get an output for 600. All right, now that I have values on the h-axis, I can figure out my scale, which is my pattern. Remember, what is pattern? Well, let me explain it to you with the d-axis. From 0 to 10, I'm adding 10. From 10 to 20, I'm adding 10. This is my scale. That is my pattern. But for this one, they're asking for the scale for h. So what is my pattern? From 300 to 450, I'm adding 150. From 450 to 600, I'm adding 150. So what's my scale? My scale is 150, and I'm adding. So this is my final answer. You do have to figure out the values of the h-axis to figure out the scale. So yes, it's going to require some work. After the work, you should be able to see the scale right away. All right, can you guys try the next one? All right, for this one, it says, suppose a local community is having a movie night in the park to raise money. All right, keep in mind that we are raising money. Raising money means that we're making money, right? Okay, they think that 50 adults and 1/5 of children will attend. It will cost $300 to put the movie night. They want to raise $1,500. Identify two variables that can be graphed for this situation. All right. So my question is just identifying the two variables. We were doing this in Target 3C, right? We were writing the equation, and then you were telling what the variable means. So it's the same thing. We have to write an equation. Okay. I have told you, and I keep telling you guys, that y is always going to be the total. It means the total. All right. Well, what's the total for this? How much money they want to raise? All right, they want to raise 1,500. That's their goal. They want to raise this much. They know that they're gonna have to put 300 just for the movie night. It's gonna cost 300 just for the movie night. Okay. I also know that I have 50 adults and 150 children attending the movie night. Okay, but I keep saying there's no equation if we have no variables. So far, I have no variables in this equation, so I cannot even say that this is an equation. I need my variables. Well, since they are raising money, I need to know something about those adults and children for me to raise money. I know 50 of them are coming. 50 adults are coming. Do I know how much money am I going to make just for the adults? No, I do not. Okay? That means that A represents the cost of adults. And same thing with the children. I know 150 are coming, but do I know how much money am I going to make out from the children? I do not. Why? Because I do not know how much is the cost of children. How much am I going to be charging for adults and children? That's something I don't know. So That's why they're my variables. And that's it. All we have to do was identify the two variables, and I did. My answer is right here. All right, try the next one for me. Okay, just like we did the other graph when we had to label the y-axis, we have to do the same thing with this graph. However, notice that this graph is completely empty. So that means we have to label the y-axis and the x-axis. We have to write the numbers. We have to write how much is it going by, and we have to talk about what is it talking about. All right, like I said before, you need to read each sentence one by one. Okay, so let's read the first one. It says the following graph shows the number of households as percent in the United States that have a computer every year starting from 1997. All right, with just the very first sentence, I already know that we're talking about computers from every year starting at the year of 1997. All right, and I keep saying that X is going to be your independent, right? Your independent means that it doesn't need anything to change. Y is the dependent, right? Y needs of X. All right, well, think about it. We're talking about computers over time, every year, right? So where am I going to put time and computers? We know that time changes all the time, and it doesn't need anything to change. The time is changing no matter what time. It doesn't matter of anything. The time's gonna keep going no matter what. So that I know for sure that independent has to be time. Time in years. And so far from the very first sentence, I know that starting in 1997. Okay, that means that my dependent, the amount of computers a household has, depends on the time of the years. And they told you it's a percentage. All right, I keep reading. It says in 1997, 35 of the households had a computer. All right, that means that at 1997, the very first point has to be 35%. Right, that's how much they started. Okay, each year, the number of households with a computer increased by 6%. They're already telling you that it's increasing by 6%, so this has to be your scale. The pattern, how much is it going by all the time? Okay, they told you each year, that means it's going each year by one. So if this is 1997, the next one has to be 98. And notice I'm focusing on the lines that connect with my points. I'm not connecting the lines from the graph. Okay, I'm not using these little lines. I'm not skipping them. I'm using the lines with the points. Then the next one has to be 2001. And the only reason I connect my lines and I'm making the lines is because it helps me. Okay, it helps me keep track of what years with what point. Okay, well, they told you it's increasing by 6%. That means that the computers is increasing by 6%. So what's 35 plus 6? Well, 35 plus 6 gives me 41. So that means that the next one has to be 41%. What about the next one? I keep adding 6. It's going to be 47%. What about the next one? It has to be 53. All right, what about the next one? Well, it has to be 59. And the last point has to be 65. All right, and we label the y-axis, we label the x, we figure out our numbers, and we are done. Okay, that's it. That's all we have to do. Just complete our graph. So can you guys try the next one? All right, the very first, last one, sorry. All right, very last problem can get confusing, and like I said, you don't want to read the whole problem all at once. You want to take each sentence at a time because you will get confused, especially with this problem like this. Okay, so it says suppose Wilma and Greg are traveling north along a road. So we're talking about two people. We're talking about Wilma and Greg. Okay, so you need to identify which line represents which person. Okay, it says Greg travels at a constant speed of 4 miles per hour for 1 hour, then stops for 1 hour. All right, so based on just the information I just read, okay, I'm not moving on. I'm focusing on that so far. We are talking from miles per hour. So again, I told you guys time has to always be on the x-axis. And time is going to be presented by hours. Okay, and what is going to be presented by the y? Well, it's talking about miles. So it has to be distance, right? The distance traveled in miles. Okay, and they told you he traveled at a constant speed of 4 miles per hour for 1 hour. Just on the graph, I can see that this line right here is the 4 miles per hour. That means that this has to be the very first hour, and this has to be the 4 miles. That has to be 1 hour, has to represent 4. Again, you don't get it? When I have 1 hour, I have 4 miles. That's what's happening. All right, and then it tells you then it stops for 1 hour. That means that this is a stop. They stop for 1 hour. That means that the next one is my second hour. Okay? All right, keep going. It says Greg then speeds up and goes to a constant speed of 6 miles per hour for the next hour. All right, the next hour is this. This is happening. He's traveling 6 miles per hour, and this has to be the third hour. Okay, in total, after 3 hours, he's traveling at a constant speed of 60 miles. How do I get 60? Well, he started at 4, right? He started at 4 and he went up 6. So 6 plus 4 gives me 10. That's how I get 10 miles. He has been traveling for 10 miles now. All right, and then once again, he stops for 2 hours. This is the other 2 hours. So this has to be 5. 3 plus 2 gives me 5. And you can notice that it's going 1 hour at a time. So there you go. It says when he starts up again, he travels 2 miles per hour for the last hour. So the last hour is 6, and this is the 2. So I'm going by 2. But he's starting at 10, right? Plus 2 gives me 12. All right, so that means that this line right here represents Greg. And I couldn't notice that from the beginning because it tells you Greg travels at a constant speed of 4 miles per hour, then stops. The only person that stops and has been stopping is the solid line, the one I just traced. The dashed line has to be Wilma. Alright, and then they tell you Wilma starts at the same time that Greg starts, right? They start at 0, right? They both start at the same time, which is 0. But Wilma starts at 4 miles farther north than Greg. So Greg started at 0 miles, Wilma starts at 4 miles. And it makes sense with my graph, right? And then it says that she travels at a constant speed of 1 mile per hour throughout the trip. She never stops, she never changes speed, so there you go. 1 mile per hour. And that's all we have to do. We label our X's or Y, we identify who's who, and we label our numbers. Alright, so hopefully 3D notes are not that hard. All we have to do is figure out a graph or equation to the graph and read real world problems that represents the graph. Alright, so if you have any questions, just make sure to start coming in for extra help. And you can always use Remind to send me questions. Hopefully this helps.